Arduino for Beginners, episode 28. How to use stepper motors with your Arduino. Now, the easiest way to control a stepper motor, unless you are using a real small one that hardly uses any current, you're not going to be able to drive it directly off the Arduino. If it was one of those ones like you find in your CD-ROM drives, those I think you could probably get away with driving directly from the Arduino board, but otherwise you're going to use something like what I have here, which is an L298N H-bridge. It's actually a dual H-bridge because you need that to be able to control the stepper. A single H-bridge won't work. But you can use these for controlling two DC motors, or you can use it to control one stepper motor. Now it's pretty easy to hook up here. Let me see, where's my power supply so I can plug it in. I'll show you it working here. Oh, give me just a second. I forgot to plug it in before I started the camera. There we go. Now we've got some power. As you can see, I have it here. I'm running the sketch that's in the examples, and we'll go over that in a minute here. And as you can see, it's turning. It goes one rotation one way, then one rotation all the way around the other. But you can change that. Actually, in the next video, we're going to take a look at a combination between this video and the last video, which was rotary encoders, and we're going to use a rotary encoder to control the stepper motor. But to hook it up to your H-bridge, there's 6 pins on here. Now, the two outer ones have dual pins. Now, when you get this in the mail from wherever you order it from, it should have 2 jumpers on here. Now, this one doesn't have the jumpers. I use this one for my DC motors, and those 2 pins you use to control the speed. With a stepper, you don't. What you want to have is that jumper on them 2 outer pins. Then you have your 4 inner pins here, and you connect that to pins. I have it set up between pin 8, 9, 10, and 11. You can change that in the sketch and use other pins. It's just convenient. That's how I hooked it up. Then I'm running, this can run up to 12 volts. Now this stepper won't handle 12, this will only handle 9. So what I'm doing is I'm using a 9-volt power supply, and then I'm taking off the VN pin. The VN pin on the Arduino board is going to be the same voltage that comes in to your Arduino. It's not going to be the 5 volts, so I have 9 coming in, and that's supplying the H-bridge's power, and then I have it plugged into the ground. Now if you supply this with 12 volts, there is a 5-volt pin on here that you can in turn use to power your Arduino. But being this stepper will only handle 9 volts, if I do the 12, it'll fry it out and it won't work. Then what you do is you take your 2 pairs, and you've got side 1 and side 2, and you hook your wires to both sides. Now if the stepper is not turning the way you want it to, on just one side, and only one side, switch the 2 wires, and that'll change the direction that the stepper moves. Otherwise, to figure out which wires are connected, you can just use a voltmeter and check for continuity between the 2. You want the 2 that you're going to get continuity from connected to each side. So easy enough to figure that out. Otherwise, that's all we got for how to set this up. So we'll go over, this is sketches in the example, but I'm just going to go over it quick with you so you understand it, what it's doing and how you can modify different things in it. Excuse me. And then, like I said, in the next episode, we're going to take a look at using a rotary encoder to control this. And then I'm going to probably put together some project to show a practical use of that, which is something in the real world you'd use it for. So, all right, well, I'm going to turn the computer on, and I'll catch you over there in just a moment. We'll take a look at the Arduino sketch. All right, I got the Arduino IDE opened up. And all you do for the sketch is go under File, under Examples, and then down here under Stepper. The one we're using is the one Revolution. There are a couple other ones here you can check out as well, but this is the one we're dealing with today. So we've got a library we're putting in here. Now this should already be included in your Arduino IDE. You should not have to add this. It should already be included. If for some strange reason it got deleted or you don't have it, you can, what is that, under Sketch, include library, manage libraries, and you can search for it. It's easy to find if you did lose it. Then we got here is a constant int that this is the number of revolutions that we're making the motor go, and then it'll switch direction and go the other way. We're doing 200. So if you wanted, you change this any number you want. Actually, for most of the way you'd be using this to control it, you wouldn't even have this. This is just an example. Then right here, we're setting which pins the stepper's on. So if you use different pins, like I said, you could just change the numbers here. Then under the void setup, we've got a set speed here. Now 60 is the default. Now if your stepper motor is not wanting to work correctly, it's like being jumpy, it doesn't want to turn right, try increasing this number to start with. And if that don't work, try decreasing it. I have some steppers I use. A lot of them will run at the 60 here. Some of them will run better at 80, and I have a few that you have to be in the hundreds for them to run properly. And then this serial up again, this is just an option to serial print if it's turning clockwise or counterclockwise on your cellular monitor. It's nothing you really need to have in this to begin with, in my opinion. But all right, then what we're doing is we're just going to mystepper.step, which is telling it to move, and we're doing the steps per revolution. That's this number here. Otherwise, if you were using this to control something and you had like a push button and you wanted it to go 10 steps when you push the button clockwise, well then just put the number 10 in here. If you want it to go in reverse, what we're doing down here is after this completes the cycle, it's doing the opposite. It's doing the negative. And once again, if you used a push button, you could just use this command with minus 10 steps or 20 or whatever you wanted it to do. And when we get over to the rotary encoder here in the next episode, you'll see, because the rotary encoder I'm using as a push button, and we're going to set it up so the stepper will just normally click one step every time you do one click on the rotary encoder. But if you have the button pushed down while you're clicking it, we're going to have it move like 10 or 20 steps each click. All right, well, that's all there is to this. I just wanted to do a quick run through on this, being that the next episode is going to deal with using this with a rotary encoder, and then after that we're going to make a project, something to show an actual real-life use of this stuff. So, all right, well, thank you for joining us here today. If you found this information useful, please give me a thumbs up. Appreciate it. I hope you have a great day, and remember, have fun building.